you use a pen, all right, or a marker. Number 1, accuracy is defined as how close the measured value is to the true value. The smallest increment. Smallest increment is precision, right? So that can't be it. How close the measured values are to each other? No. The difference between the two measured values? No, it is A. Okay? That is the definition of accuracy. How close you are to the true value. An object weight on a balance is determined to weigh 0.05 grams. What is the precision of the balance? Right? So the precision is found on that last decimal. So you basically rewrite the number with a bunch of zeros and then just put a 1 on that last place value. Okay? So D is the right answer. The wingspan of a female red-tailed hawk being monitored, and it's 130 centimeters. What are the precision uncertainty of this measurement? Okay, so the precision lies on the last one. It's 1 centimeter. The uncertainty is plus or minus 0.5 of a centimeter. Okay, so we have precision is, no, that can't be, because precision cannot be 10 centimeters. I feel like there's a mistake on this one. I think A would be the, I think it was supposed to go 1 centimeter or 10 millimeters. That's what it was supposed to say. Because it's the same, right? 1 centimeter is 10 millimeters. So this one is kind of weird. I think I will just omit this one in our calculation because it's not fair. Unless, I mean, I think you could have ruled out the other ones, to be honest. But, yeah, I have to check that one. 4, Jeanette measured the length of a piece of copper pipe. True length is this, using a tape measure marked at 0.1 centimeter increments. What is the most precise measurement she can record? Okay, so your precision is 0.1 of a centimeter. So this measurement here, the closest you can possibly get is going to be 0.7 or 17.8. Right, that's the best you can do. So in this case, it would be this one, 17.7. Right, because this part, it's almost like saying this is what it's supposed to be, but the device you're using to measure can only go to the nearest 1/10 of a centimeter. It cannot see what's past there. Okay, so this is the answer there. It's kind of weird the way it's phrased, but I think it, right, if you think about it, it will make sense. There's a relay team. The times are as follows, right? If the times are added together, how long would it take for the team to complete a 20-kilometer race, including uncertainty, right? So this is the key here. So if I look at their times, okay, if they all have the same precision, which they all do, then we can just on the side say here, precision is 1 second. So it's minutes and seconds, right? So it's at the end here, so it's 1 second is the closest, that's my precision, smallest increment. Therefore, the uncertainty is plus or minus 0.5 for every single one of them. So if you add this up, .06 and 2114. You also have to add every single time the uncertainty. Okay, you have to add all their uncertainty. So if you figured out this precision and uncertainty, I give you 1 mark already. And then I will give you 1 mark for adding the times and 1 mark for adding all the uncertainties. So if you add up all the times, you get 76 minutes and, sorry, 75 minutes and 73 seconds, okay, like this, plus or minus, if you add up all these, you get 2 plus or minus 2 seconds, okay. Some of you may have said, hey, you can't have more than 60 seconds, right? So you take away 60 from this and add 1 minute to the time, right? So it'd be 76 minutes and 13 seconds, plus or minus 2 seconds. I would be okay with either one of these, okay? So either one of those answers. So I'll give you 1 mark for the time and 1 mark for the combined uncertainty added on. So it's kind of weird because it's time, we're not used to it as much, but it did tell you what's what, right? So there's nothing to enter here, it's just out of 3, right? So you just get a mark out of 3 for this one. A doctor measures a dose of 2 milliliters of medicine for a child. What is the precision and uncertainty of this measurement? The precision, because of the decimals, is this, and the uncertainty is half of that, as just like that. So I'll give you 1 mark for each today. If you got your precision wrong, -1, you still get a mark for stating the uncertainty based on your precision. Which of the following is most precise? So they're all in millimeters, so the units you don't have to worry about. And so you would want the one that has the most decimals, right? So this one right here is the most precise measurement you can possibly have. So this page, you got to be careful because the 2 and the 3, this adds up to 5, right? And then we go 6, 7, 8, 9, 10, 11, but I said I was going to omit this one. So we're going to make it out of 10. This backs, the first page is out of 10. All right, flip it over. That is the length of the black bar, including the uncertainty. So again, it's up to you. You want to use millimeters or centimeters. If you use millimeters, this thing is 62 millimeters, right? Millimeters, sorry, plus or minus. We have to figure out what the precision is on uncertainty based on the picture. If you use millimeters, the precision is 1 millimeter. And the uncertainty is plus or minus 0.5 of a millimeter. Okay, so we can just tack on 0.5 of a millimeter like this. Okay, I would say 1 mark for 62, 1 mark for the uncertainty. Or if you use centimeters, you would go, 6.2 centimeters plus or minus. Well, you got to go up here and say that the precision could also be 0.1 of a centimeter. Therefore, your uncertainty is plus or minus 0.05 of a centimeter, right? So you have choices there. This is always going to be the case for a metric ruler, okay? So you don't have to overthink this. Maybe just add it to your study sheet if you need. Like a metric ruler, the smallest on a ruler would be a millimeter. Of course, it can get smaller, right? You can get smaller, but a ruler usually doesn't go smaller than that. So that would be 0.00, sorry, not too many zeros, right? There. So if you want centimeters, I'm okay with that. You could just state it like that. Okay. Which of the following describes the concept of tolerance in measurement? The length of a gutter must be a minimum of 12. No, not yet. A drilled hole has to be big enough to fit a 5 millimeter dowel, but small enough for the dowel not to fall out. I would say that's probably it, but let's keep reading. The combined weight of 6 items weighed separately will have a higher uncertainty. We're talking uncertainty there. The average weight of a pumpkin is 2.5, also not it. That's not really talking about tolerance. Tolerance is, right, what we allow for something to still be used for its purpose, and so it's B here. B is the right answer for that one. Think of this, right? It's making an indication of of this, right? It has to be small enough or big enough, right? It has to be in between two things for it to still be acceptable. So that's what tolerance aims to address, okay? Here, the nominal value is defined as, it's the target value of a measurement, right? C is what we're after there. The range of possible values, folks, that would be tolerance. The minimum value of a measurement, not it. The target, yes. The maximum, not it, right? It's just talking about the greatest possible that we allow. Okay, next. Which of the following is another way of expressing the tolerance here? So which one of these would say the same thing as that? And I told you already, right? Come up with your max. Come up with your min. Your tolerance is the difference between those two. Tolerance is 0.01 inches. Okay. So we've got our max, min, tolerance. Nominal is going to be in between, right? So I add and divide it by 2. That's 0.76 of an inch. Okay, you do your inventory here and then you check. This one follows the nominal plus or minus half of the tolerance. Is this the nominal? No. So fails, right? Just having one number, definitely not it, right? So it fails. So it's going to be one of these two. Let's see. Would this make sense? This is the min minus 0 plus tolerance. That's what this is trying to say, right? This is the format that you identify, and it does meet the requirements, right? My min is that, which I know is correct. I go minus 0, I go plus tolerance. So this is it, unless, did you check for this one? This is definitely not the nominal either, right? It doesn't follow this format really, because the nominal is supposed to be 0.76. So all of these fail except for the one. So that's why having this inventory is, I'm telling you, if you know how to do that, you're going to be in good shape. Given the tolerance of a pipe, so what they're trying to say is this is what we want, but it can be off by a bit, we'll still accept it. Okay, that's what tolerance is trying to say. Half of 0.9, I want to take my time here. All you do is, right, you grab your calculator and either multiply it by half or divide it by 2, whatever you want to do, it's the same thing. So really it's plus or minus 0.45. Okay, so to kind of summarize that. So again, you go max, min, tolerance, nominal. And I hope you all got it right and just watching to see if you did it right. So the maximum, if you add these two, right, so I already have the tolerance, I'm just going to add at 64.95. And then the min is 64.5 minus 0.45 at 64.05. Tolerance is just the difference, it's just 0.9, which we already expected that, right? This is just to make sure we are in fact doing this right. And so all of these do not give you marks really, okay, unless they did ask you to fill in the blank, for example. But now we can proceed with this. Max min, just copy that down. 64.95 centimeters, 64.05 centimeters. This one calls for minimum first, minus 0 centimeters plus 0.9 centimeters. And then the next one, it calls for max plus 0 centimeters. Oh, centimeters everywhere, okay? Minus 0.9 of a centimeter. So there you have your three formats. We'll give you 1 mark for each. Okay, 1 mark for each of them done correctly. I will be reasonable. So let's say you make a mistake here in your inventory and then you use that to rewrite. I would go -1 once, and then the other ones I would base it on what you have here, because then I understand that you get what needs to happen. You just made a mistake somewhere here. The only way you would lose even more marks is if you rewrite it wrong, right? If it still doesn't jive with what you have here moving forward, okay? All right, let's do the adding up here. 3, 4, 5, 6, 7, 8, right? So the ruler is worth 2 marks. So we are out of 8 on the back side here. So add it up, 8 and, what was it, 10? 8 and 10 makes this whole thing 18, so not 17, because I made some changes. So just cross that 17 out and just make it out of 18. Name and last name, please.